Okay, so the concept that we're going to do now is from vectors in IGCSE Additional Math. And this one involves the resultant of vectors and the use of trigonometry in it, like cosine rule, sine rule, and basic trigonometric ratios, sine, cos, and tan. And I've selected about 9 questions, of which I'll explain about 4 of them, and the rest you have to do. I'll tell you the serial number of the questions that you would want to do from the P2 book. Okay, so here we start. The first thing that you want to know from this part is the cosine rule. And so you know a square is a b square plus c square minus 2bc cos of a. And the sine rule, where it is a divided by sine of a is equal to b divided by sine of b equals c divided by sine of c. And all of this, uh, the ones that I have written here, is for any triangle which has the sides named A, B, and C. And the angles are, uh, so you know it's supposed to be the side small b against the angle B there. And it's kind of confusing if you look at it with a triangle there, but you should know if you're looking for one side, it's going to be the other two sides here, B and C, if you're looking for A. And the angle opposite to that side, A, should be out here. Okay, same here. A divided by the sine of the angle opposite to it. B, the side divided by the sine of the angle opposite to it. That's how sine rule and cosine rule are supposed to be used. Okay, so we go do this question. So the most important thing in these kind of questions is to be able to draw the situation. So if there's a plane which can travel at that speed and it heads due north, so there, I can show you the diagram. There it is, the one on the right out here. Let's go keep it here like that. Okay, so there it is. This is the plane going north. The plane is blown off course by a wind so that it travels on a bearing of 10 degrees. So there it is. The blue line, the blue arrow shows the direction of the plane after it has been blown off course by the wind. So the blue thing is where it is. Now, by the triangle law of vector addition, you should know if there was a velocity which was supposed to be this way, and because of wind, it has come along this direction, it must have come from a wind which was directed this way. And that is how this happens to be the resultant of this one and this one. Okay, so that is the diagram now. What is it? 300 supposed to be north, 280 at a bearing of 10 because there was wind in that direction coming onto the plane, which actually blows it off course. So that was the situation. Now, if they want me to find out the speed of the wind, I know there is a triangle out here. I can use cosine rule to find out the value of x, the speed of the wind. And that's what I do. There it is. There. X square equals 300 square plus 280 square minus 300, 280. Like I told you, if there is x you're trying to find, it should be the cos of the angle opposite to that x. There's 10 degrees out here. That's the bearing. The speed of the wind comes out to be 54.34 kilometer per hour. Okay. Now, in the next part, they ask you for the direction of the wind as a bearing correct to nearest degree. Okay. So we will look at the diagram again. So there is your wind x. And when they ask you for the bearing, you know it should be the angle it makes with the north going clockwise. So that is the angle you're looking for. That's the bearing. And for this one, what I do is I find out the angle theta first. This angle I find out because I can, using sine rule. I can find this one out using sine rule on that triangle. And there it is, the setup for the angle theta here. Sine of 10 divided by x should be equal to sine of theta divided by the side opposite to theta. It's a 280 there. Sine 10 by x equals sine theta by 280. And then I solve for theta, comes out to be 63.5. There. This angle comes out to be 63.5. And of course, because of that, the bearing is going to be 180 minus 63.5, comes out to be 106.5. But since they want it to be correct to nearest degree, I'm going to have to put up a 117 here. Okay, one mistake that people may do with cosine rule is they may write this as the answer for the speed of the wind. Just know that what you get out of this cosine rule is the value of x square, the square of the wind speed. So x is going to be square root of that, comes out to be 54.34. Okay, so that was this question. Let's look at another one now. Okay, now here we have a swimmer, which was, she was supposed to go from A towards B. But because of the river here, she is again blown off course and she finds herself at C instead. Okay. And now they're like, what is the time taken for her to reach the point C? And they also want us to find out the distance she went away from B. BC is what she want us to find out, or they want us to find out, and the time it takes for the swimmer to go from A to C. Okay, so I have the setup here, A to B. This is where the swimmer was going. If you can see, she swims from point A and aims for point B, which is directly opposite, but she is carried downstream to C. Okay, so again, I have the setup here. 1.6 is the velocity she can go with. 0.5 is the velocity the river is going at, and VR would be the resultant of these two. And again, I use Pythagoras theorem and I find out the resultant velocity. I call it VR. And it comes out to be 1.67. Resultant velocity comes out to be 1.67 meter per second. So she ends up going along AC with a velocity of 1.67 meter per second. Okay. Uh, let's find out the distance AC should be. For that, I need this angle. And I know that tan of that angle is supposed to be 0.5 by 1.6, opposite by adjacent, comes out to be 17.35 degrees. This angle comes out to be 17.35 degrees. Okay. Now, with that angle, I try to find out the distance AC from the same triangle, but this time I know that the length AB is 104. So I go cos of theta is supposed to be AB by AC. So AB by AC, base and opposite. Base and hypotenuse. Cos of theta is supposed to be base by hypotenuse. So I go AB divided by AC. AC comes out to be AB divided by cos of theta. Theta I already know is a 17.35 and it comes out to be 108.95 meters. Now, if they ask you for the time, well, time is supposed to be distance divided by speed. The distance AC is 108.95 and the speed with which the swimmer moves along AC is a 1.67. That is also something we have found out. And that is how we know that it is going to take the swimmer 65 seconds, 65 seconds to move from A to C. That's your answer for the time. What about the distance BC? Well, I use the trigonometric ratio tan here. So tan of theta is supposed to be BC divided by AB. And I know BC is going to be AB tan theta. That's 104 into tan of 17.35. BC comes out to be 32.5 meters. So she is blown, of course, by 32.5 meters because of the river. Okay, so that was another question. Again, drawing the situation helps with questions like these. Okay, so let's go look at another question now. Let's see. We have a plane here. Yeah, there, this one. So this is 434 from the 13th chapter on the P2 book. What do we have here? We have a plane which heads due north. So there it is, the plane moving north. Let's zoom around the sketch. And a wind with 40 kilometer per hour from a bearing of 310 blows the plane off course. Okay. So the thing is to be able to locate the direction of the wind. So you should be able to locate how the wind moves into this diagram, onto the plane. So when they say there's supposed to be a bearing of 310, it's gonna be this angle there. That's 310 degrees. And the wind comes onto the plane from that bearing. So that is the arrow to keep them aligned in a way. I can use triangle law of vector addition. I'm going to take this velocity up, in fact, down, place it here like that. And now I have the velocity pointed in a way. The tail of that velocity of the wind is placed on the head of the velocity of the plane. So there, like that. So when I go keep it like that, it is aligned. These vectors are aligned in a way I can use triangle law here of vector addition. So now I've placed it here. Because of these two vectors, this one from the plane, this one from the wind, the plane actually ends up along this direction. That's VR for you, resultant velocity in a way. Now, if this angle is a 310, you should know that this is a 40, which means this is a 40, which means this is a 50. Okay, why is this a 40? Only because I know that this angle is a 270. Okay, so now I have the angles, I have the triangle drawn properly. I can go about find anything that they have asked for. So they ask you for the resultant speed of the plane. So there it is. This is what they're asking for. So I'll go use cosine rule here. There. VR square is supposed to be 260 square plus a 40 square. That's the wind's speed minus 2 into 260 into 40 into cos of the angle between those two velocities, 260 and 40. There's a 50-degree angle between them. And the velocity resultant comes out to be 236.3. And again, I have made sure that there's VR square being talked about here. And VR is going to be the square root of this, 236.3. So that's the resultant velocity the plane is going to move with. Okay. Now, let's look at any other thing. So they asked for a bearing of the plane. Well, so what they have asked for is the bearing of the resultant velocity. Watch. If this is where the plane ends up going from the north, this is the bearing they're talking about. And I can find it out from that triangle. It's very simple. I go sine of that angle, let's call it theta, sine theta divided by 40 is equal to sine of 50 divided by VR, the one that I found. theta comes out to be sine inverse of 0.129, and it is 7.45 degrees. You can write it as 7.5 degrees. That's the bearing of the velocity. So we got the answers. They're supposed to be 7.5 on the bearing and 236.3 on the speed of the plane. Okay, so that was another question. Okay, let's look at another one now. Here. Calculate the magnitude and the bearing of the resultant of 10 meter per second on a bearing of 240 and 5 meter per second due south. Okay, so there. And let's keep the question also on the side. Let's keep it like that. So now you have velocity of 10. Let's there. Velocity of 10 at a bearing of 240. So this is 240, which means this is 60. And then there is 5 meter per second due south. So there is this velocity, which is 5 meter per second, and it's due south. So that's the direction of it. What I do again is I align them in a way the head of one is on the tail of the other vector. So once I do that, now I can very nicely use triangle law of vector addition. This is 5. Its head placed on the tail of this velocity. 10 on this guy, 5 on this guy. Of course, the resultant is going to be the blue thing that I've drawn here. That's the resultant. Okay. So that was the setup. But we need angles between the vectors. So what do? I know that this is supposed to be 60, which makes this a 120. And let's see, they asked you for the resultant, right? The magnitude of the resultant. Well, there it is, the resultant. What is the magnitude of it going to be? I'm going to use the sine rule again. So there, let's see. VR square equals 10 square plus 5 square minus all of that cos of 120. That's the angle between the two. The resultant velocity comes out to be 13.3 meter per second. And now they can ask you for the bearing also. They have asked you for the bearing. So we go look at the diagram again. There. This is the resultant velocity. And the bearing it has is supposed to be this thing. For that, I'm going to find out this angle. To find out that angle, I'm going to use sine rule in the triangle. And there is the setup. There. Sine theta by 10. Sine of theta divided by the side opposite to it. 10. Sine of 120 divided by the side opposite to it. That's VR for you, 13.3. Sine of theta, 0.65. Theta is a 40.9 degrees. Now I have this angle. Okay. If they ask you for the bearing, it's gonna be equal to 180. Let's see. This came out to be this thing came out to be 40.9. Bearing is gonna be this whole thing. 180 plus 40.9 comes out to be 220.9 degrees. Okay. So those were a few questions I wanted to discuss. Okay. Now what I do is I tell you the questions you would want to do just to finish off this concept. You write them down. The P2 book you want to go to. Okay. In the P2 book, you want to take up 439. Let's write them down. That's 439, question number 439, page number 538, chapter 13, P2 book. Next, 446, P2 book. 448, 452, 453, 455, and 459. 1, 2, 3, 4, 5, 6, 7 questions. 7 questions if you do. And of course, if you have any doubts in there and you're not able to sketch the situation, and maybe you're not matching with the answers, your answer is not matching with the ones at the back. So answers are always at the back, you should know. If they don't match, you tell me. I'll explain it again. Okay. So these are all 439, 446, 448, 452, 453, 455, 459 from the P2 book and chapter 13. And this is what you want to do to finish this concept off. I'll see you. Bye bye.